All right. Hello, everybody. Good morning. Welcome back to Comp 2452. I want to say that I'm deeply conflicted that I saw some geese the other day because it means two things. One is that the geese are back. But two, it means they're bringing spring with them. And so I'm pretty conflicted about that. It's supposed to be pretty nice today, so I'm kind of looking forward to a nicer afternoon, although it's going to be pretty puddly. So we did hatch our dragon egg in the section yesterday afternoon because, of course, there's a cookie dragon in the cookie clicking game. When you get Crumblor, the cookie dragon, it's going to upgrade itself. So we've got a couple 100 million cookies here, so I'll upgrade Crumblor for you. Now that we've done this, we can start attaching Dragon Aura. So I'm going to add Breath of Milk. That's going to make my milk more effective. But the next thing that I have to do here is I have to sacrifice 100 cursors. So it's no longer just sacrificing cookies. I've got to give up buildings to be able to upgrade Crumblor. So I'm not actually sure if we're going to be able to buy 100 cursors. Well, we can. Okay, so let's sacrifice 100 cursors. Next, we have to sacrifice our grandmas. But I'm not going to do that because that sounds terrible. I'll just buy 100 more cursors, and we'll buy as many upgrades as we can right now. We're getting substantially more cookies per second than we were a minute ago here, I guess. But I don't know. We can just buy a few of these buildings, and things go fast after you've done that ascension. The game starts to basically play itself here, where you can just kind of, very rapidly upgrade stuff because you're just getting all sorts of stuff real fast. Anyway, let's stop playing Cookie Clicker and let's start talking about the course. The main thing that I want you to be able to do by the end of today's lecture is we're moving on to a new topic, and the main thing I want you to be able to do here is implement a state machine. So this is actually something that comes back from Comp 2400. You were asked to implement a state machine there. I'm going to ask you possibly to implement a state machine here. But the purpose of implementing the state machine for us is different than what you did in Comp 2400. My understanding of what you did in Comp 2400 was build a state machine kind of for the sake of building a state machine, go through the different states of a state machine in code. The goal that we have for this course is to take that idea of state machines and use it as a tool to help effectively validate input, to validate different kinds of complex input. I guess for context for all of you, the goal for me for this course is not to use this as a tool to validate inputs. I'm actually not going to ask you to implement this as part of your projects. This is not something I'm going to do. It's not going to be surprise, there's 10 or 15 more hours of work to do on this. That's not what I'm going to do. The purpose of this for us, at least in this course for this offering, is I want to use this as a stepping stone toward Markov chains. So using state machines here is going to give us enough of a background on the structure and the overall flow of operations with state machines that you should have a pretty good sense of how Markov chains work when we get to them next week. But the goal that I have really is that once we've done the stuff that we're talking about with state machines, you really ought to be able to implement a state machine to do validation of things like email addresses as input. So in accepting or rejecting inputs. We have a test 1 week from today, and so I promised to talk about it today, and I promised to give you some time to ask questions about the test and the project, so I'm going to do that today before we talk about state machines at all. The term test is going to be in class. It's the same kind of structure as what we had for our first term test. It's going to be the whole class. I'm saying this again because I want to make sure it's clear to you that I don't plan to lecture on that day. That's not something we're going to do. The class is going to be allocated in its entirety for the test. The coverage of this term test is going to be on topics that are between term test 1 and up to Tuesday's class next week inclusive, with the same caveat as last time where, like, if anything from this class or next Tuesday's class shows up, it's going to be minimal in comparison to the other material that's going to be on the test. This test is not an intentionally cumulative test. Like, it's not going to have the same exact questions as you saw for term test 1. If there's anything that's related to term test 1 on this test, it's kind of out of, like, we've built upon that idea, but we're not going to be doing things like, for example, and I'm going to say this again, there's going to be no questions where I'm asking you to implement a view in this test. Just to give you a sense of what I mean by, like, everything between term test 1 and up to next Tuesday. As with term test 1, the seating is assigned, so you should attend the section that you're registered for. If you've registered to write your test in an alternate location with Student Accessibility Services, you should go to that location, and the test that has your name on it will be provided to you. There will be programming on this test, but I mean, consider the kinds of programming that we've done since term test 1. Keep that in your head in terms of the kinds of things that you could expect to see. There are no strict syntax concerns, as there weren't any strict syntax concerns with term test 1. So I really don't want you to, I still don't want you to memorize HTML, but I am going to say that your SQL should at least look like SQL. In the last term test, I didn't expect you to write any SQL. I was really just expecting you to run it in your head. This time, I will be expecting you to write some kind of SQL code, but when I'm saying things like no strict syntax concerns here, what I really mean is, like, if you forget to put parenthesis around something, I don't really care that much. If you've misspelled the word select, I don't really care that much. Like, I'm going to give some flexibility in that sense, but the SQL that you write for this test should look like SQL. It should be SQL structured. When you're writing SQL for this test, please make sure that you're using only structures that we've talked about. So if you have some outside knowledge of SQL, like joins, for example, any questions I'm writing will not intentionally be requiring the use of anything like that. So please just don't use those kinds of things if you happen to know about them from outside the course. Please don't memorize HTML. There are definitely going to be no right of view question on this test. There will be nothing like that on this test, so please don't spend any time memorizing any HTML. You could expect to see questions about the HCI content that we've been talking about, so assessing user interfaces. Assuming that there are questions like that on this test, the interfaces that I'm going to ask you to assess will either be provided to you as screenshots on the test, or they will be well known to you. So they will be interfaces that you've seen and used before extensively, either as part of the course material that we've been doing or just outside of the course in your regular life. I don't want you to memorize the MS-DOS installer. That's definitely not going to be part of the test. I think that that was a valuable exercise for us to go through in terms of doing an assessment of that interface, but I really don't want you to spend any time memorizing how that looked. If I'm going to ask you questions about anything, I will give you the interface, or I will give you an interface that you are already well familiar with. There will be no questions about Cookie Clicker, there will be no questions about ordering pizza, and there will be no questions about installing MS-DOS on this test. So you don't have to worry about those showing up. I want to give you a chance to ask some questions here. I'm noting that my camera is flickering back and forth. So if you're watching this on the live stream, you're going to see me from different angles today. I'm going to claim that that's because I'm a real cinematographer here and it's got nothing to do with the flaky dongle that I'm using. But I'm going to give you a chance to ask some questions. The questions that I want you to have the opportunity to ask here are about either the term test or about the project. I'll give you about 5 more seconds to join here, and then I'm going to switch over to Mentimeter. All right. And then I've got a question for you. What kind of pizza is best kind of pizza? There is an absolutely wrong answer here. Please don't select it. I'll give you about 5 more seconds to answer this question. No. What did I expect to happen? Yeah. No, you're all wrong, and you should feel bad about it. Pepperoni and mushroom, I'm going to say that that's probably the best answer. Anchovy, banana, pepper, and ranch is like, gosh, I don't know, something entirely different. Fair enough, yeah. But Hawaiian is absolutely the wrong answer. Okay. I will entertain verbal questions in class, of course, but if you want to ask your question anonymously on the Mentimeter, please feel free to do so. Oh, that's a fair question. So if your UI kind of stayed the same between phase 1 and phase 2, yeah, I still think you should include that as part of your assessment of your phase 2 UI. When you're doing that, I think it would be helpful for you to even say, like, I didn't actually change this between these 2 phases, and then like just copy and paste your same assessment. I'm asking that mainly to help make sure that the grading staff have an easy time of just, they're able to go from top to bottom of your assessment and take a look at what you've written there without having to, like, you having written, oh, you should look back at my phase 1 assessment because it's the same. It just makes their lives a little bit easier to do that. Again, like, we are not assessing your UIs. We're assessing your assessment of your UIs. So it's totally okay for you to say, yeah, I didn't change this. Maybe it's still thumbs down and it's still bad, and that's totally fine. Maybe it was good the first time. That's fine. Either way is fine. I really just want to see the assessment that you have for that. So, yeah. Can we get more pictures of Walter? Yeah, maybe. I don't have any on my person today, but I'll try to include some next class, sure. Do we need to know how to implement specific database stuff like awaits, promises, and .then? All right, so some additional context about this. I have to be very honest with you that when I started preparing this course, I had no intention of talking about anything related to asynchronous stuff at all. I didn't plan to do that when I was originally planning the course, but the database that we're using, it returns awaits. It returns promises. So like the .query method on PG-Lite instances returns promises. And thus my hand was forced. I had to tell you about that. I had to tell you about this whole idea of asynchronous execution because the database tool that we were using kind of forced us to use it. In terms of what we covered in class, the thing that I'd expect you to know a little bit about awaiting, promises, then asynchronous execution at all is really about the sequence of basic operations. So in class, I'm going to pull this up right now. In class, one of the things that I showed you was, sorry, I want to get to this. One of the things I showed you in class was this repository, and this repository had a few different main instances in it, where we had a completely synchronous version of this code. And if you recall, the output from this was that it gets stuck here. It's printing A forever. Then we had something that added the keyword async, but it still behaved in exactly the same way. And then the last one was this, where we had async and we had this await operation. My expectation for you with asynchronous code is that if I were to give you code samples like this, I'd expect you to be able to kind of approximate predicting the output. Like what sequence of things would get printed by this code? What would be the output from something like this? In terms of databases and async, so I'm going to go to the project that we've been working on in class. I'm not going to expect you to write code that does stuff like this. I'm not really going to care about async and await showing up in methods if I were to ask you to write methods that look like this. that part is an implementation detail that you would immediately be told by your compiler, you need to have async, you need to have await. That part is not important to me in terms of the relationship between code and databases for TypeScript for something like a test. The main way that I'd expect you to consider things like async and await is, like I said, the way that we considered it in this repository. So kind of predicting the output of sequences of operations. If I were to ask you questions like this, it's not going to be much more than this kind of thing, like basic sequences of operations, methods that call each other, awaits, probably not having .then involved in it at all, but the kind of smaller examples like this. As with term test 1, I can't promise that I can because I just don't know that I'll have time to make a practice test. But just like term test 1, I think that part of what I'm going to say is that working on your project is a good way to prepare for this test in terms of like kind of giving yourself some practice writing SQL code, giving yourself some practice structuring your projects and stuff. Looking toward phase 3 now, and even if you haven't done your phase 2 stuff, like assessing your UI right now, like beginning to write this report would be a good way to get some practice for this test. So this is a fair question. 10 new items in the inventory can be 10 entirely new items or 10 versions of existing objects. So like 10 cursors with different kinds of stats, that would be fine. That would be absolutely fine. The main thing I'm looking for, and to give you a preview of what I'm going to give you for the implementation of phase 2 is, phase 3. I'm going to be giving you labeled training data, but the labels are my labels. And so I'm going to say things like, the sequence of purchases in this one transaction was like B1, 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 and you'll have to translate that into something in your own inventory. I'm going to say things like the next transaction were B1, B3, B2, B6, B3, 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 B6, and you'll have to translate those labels into your own internal structure. So the key thing that I really want to be able to see is that when a grading staff are looking at your page when they're loading it up, there are 10 things to buy. That's what I want to be able to see, is there's a list of 10 things that are purchasable on the page when we load it up. If they're all just variations of the same thing, fine. If they're different instances of different things, also fine. I just want to see 10 different things that we can purchase on the screen. Do we need to know about parameterized queries? I'm going to come back here, and I'm going to say that your SQL should look like SQL. We talked about parameterized queries. You should have some idea of how they're used. You should absolutely be using them in your projects. You should definitely be using them in your projects. The actual structure that you do for this is not as important to me, but yeah, you have to know about kind of like what's going on under the hood with this stuff. If you're not done, are you cooked? I mean, I don't think so. We still have a few weeks left of classes. The grading staff generally are keeping on top of things. I'm trying to publish feedback on Tuesdays and Thursdays. I'm trying to make sure that I'm keeping up with the grading staff. If you're having trouble getting some feedback, please, as always, let me know so that I can keep on top of the grading staff. But I would say that you should probably be pretty close to doing the phase 2 implementation submission right now. How would the question for consistency look like in a paper? If I'm going to ask you a question about UI related stuff, like I said, I'm going to either give you a screenshot of an interface, or I will ask you questions about interfaces that you are familiar with. So you can kind of expect it to be structured in the same sort of way that we did with the exercises in class. Like, tell me about what you think about the consistency of this thing. To size of buttons and where they are placed, also something to assess in terms of visibility, how noticeable they are. For us in this course, I'm going to say no, it's not part of visibility. The visibility assessment that we did was very much about like, are the things that we can do visible right now, or are they easy to make visible in some way? How they show up on our page isn't really something that we were thinking about in terms of visibility. I think it's an important thing to think about, but it's not part of the visibility that we were thinking about in this course. Should we expect questions about hashing and testing frameworks? I mean, I don't actually care if you know how hashing works internally. We didn't talk about how hashing works internally. We just said it does something. That was the main thing that we did, is you throw the string into this box and you get back some other string. And that's really all we care about in terms of this course for hashing. For testing frameworks, I guess I'll be clear that I would never ask you to write code that's like vtest code. Let me say it that way. I'd never ask you to write code that uses vtest's API and then assess you on your ability to use vtest's API. The thing that we really talked about in this course in terms of testing frameworks as an idea was distinguishing the idea of a framework from a library. That was the main thing that I wanted you to take from that exercise. Once we distinguish framework from a library, at that point, I'm kind of just like, here's the documentation for vtest, go ahead. I'm not printing out the documentation for vtest for you for this test. So like, I wouldn't expect those kinds of things to show up on the actual test. Same kind of thing with the practice test. I can't promise to say that I will do this. I can try, but I can't promise to say that I'll do it. I guess I will say, look back at the places where I have Mentimeters and look back at the places where I've asked you to do things in class, and those should give you a reasonable idea of the kinds of things that I might ask you to do on a test. If there are Mentimeters that I've missed or forgotten to post, I'm not doing that intentionally. Please let me know, and I'm happy to do that for sure. I mean, too late is the day after the last day of classes. I'll say that. You got to get it in as soon as you can is the best advice I think I can give you for phase 2 implementation. That's the policy that we have established in the course syllabus. But yes, I agree with you. I hope that you will do better too. If you're concerned, if you're struggling with course material, I mean, the thing I can offer for you is to just come and talk to me. If your schedule doesn't work with my office hour schedule, let's make an appointment to meet. But I am very happy to talk with you about course material. If you have questions about course material, please come talk to me. Yeah, absolutely. As always, and I want to say this again, I think I've said it a few times, but I want to say it again. When you're doing any of the modeling stuff for this course, and even for the last course, we're never asking you to make a contract. We're not asking you to build this thing up and then implement it explicitly as you've done it. My goal for this, and in general, as you get out into industry, is this is a target that I want to hit. As I'm going through and actually doing it, I'm going to find out that I was wrong. You're going to find out that you were wrong a lot when you get into a job. And that's okay. That's expected. Part of the exercise here really is, I just want you to start thinking about your design before you actually sit down and start coding. As we've scaled things up, if I were to ask you to do these major projects without doing any planning whatsoever, put yourselves back in your 10-20 shoes and imagine what would happen, what would actually happen in that circumstance. Yeah. So absolutely, it's okay. If this does change, document it. Explain to the grader how it's changed. Put some notes above your class diagram in your implementation submission to say, I changed it because of this specific reason. Can I remind? Yeah, absolutely I can. So parameterized queries were, when we're going through the process of writing queries, I'm going to go to the PG Lite API. Parameterized queries are this idea right here. So what we found was that when Red Team Walter was starting to use our Pokemon app, he was able to take over our entire team of Pokemon by injecting SQL into our SQL. He was doing SQL injection by writing strings that had SQL statements in them. And that ultimately caused us to lose ownership of our Pokemon because Walter took them from us because he wrote a bunch of insert statements and updates inside of the name of a trainer. Parameterized queries here, just in general, this is not a PG Lite thing. This is a database thing. Parameterized queries, the idea is that we're going to write our query and we're going to have placeholders for the values that we want to insert or use as input that's been provided from us to us from an untrusted source. The placeholders here are these $1 things. The separate data that we're actually submitting then is going to be in a physically separated piece of data that we're sending to our database itself. So for this query that we see on the screen right now, what's going to happen is that the value test will be injected into the statements, but it's being done by the database engine, and it's being done by the database engine after the database engine has done stuff with the query itself. And it also knows that this is not information that is going to be part of the query. This is just data to be inserted in a column. This is the idea of parameterized queries for us. I'm going to give 2 more questions here, and then if I'm unable to get to your question for today, I'm going to say please post it on the course forum, and I'll be happy to do that there. If there's no screenshot for the UI to assess, will those familiar UIs be examples we had? That would be a reasonable assumption to make, yes. It's not MS-DOS. I'm not going to ask you questions about installing MS-DOS. I might ask you to tell me what you told your parents about that class, but I'm not going to ask you questions about MS-DOS. The turnaround time is a maximum of 2 weeks. That was what the promise is. We're not withholding your feedback for 2 weeks. I'm not holding it back. I'm not holding it back. At worst, the feedback turnaround time that I get from the grading staff is like a few days after they will have done it. Are we all going to be too late because of the turnaround time? You shouldn't be. You shouldn't be. It should be fine. All right. Like I said, if I wasn't able to answer your question here, please post it on the discussion forum, and I'll be happy to answer it there. But I've got one last question for you here. As we're getting into this idea of parsing valid email addresses, what is required by a valid email address? Complicated question. That is a very good point. I'll give you about 5 more seconds to respond here. Okay. I am really, really delighted that the word @ is the very biggest thing in this word cloud. I'm really delighted to see that. I believe that means that we've all sent a lot of emails, and I very much agree with you. The domain word showing up here, I think that's also a really important thing to see. The domain is definitely an important part of a valid email address. But the one thing that I think is the most important here is the word @. Okay, awesome. Thank you all for participating in this Mentimeter, but we're going to switch back to our slides. And now I want to spend a little bit of time talking about state machines. So I've got 2 questions here that I want us to be able to go through the process of answering today as part of our discussion about using state machines to validate input. One is I still want us to be able to answer the question, what even is a state machine? What do we define to be a state machine? And I also separately want to define or be able to say, what does a state machine do? If we're given a state machine, how do we use it? What does it accomplish? How does it work? I think that you all know what a state machine is based on what you told me on the slips that I got. So thank you all for writing down that answer to the question that I gave you last time. This is a small public service announcement that's outside the scope of this course. This is some small advice for you about when you're answering questions on things like tests. And this doesn't even apply necessarily to this course, but this can apply broadly to all courses that you're in. There's a question here, and the question is, what is a state machine? This question is really asking the question, give me a definition. Tell me what a state machine is. Define what state machine is. That can mean things like telling me about the parts of a state machine. State machines have states. State machines have transitions. State machines have inputs. What is a state machine is asking, please tell me what's the definition of a state machine. What does a state machine do is a different question. What does a state machine do is asking kind of, give me an answer to this question by showing me an example of something. So show me approximately how a state machine might work. Broadly, abstractly, given inputs, a state machine will move through states. These are two different answers to those questions. One is, these are the parts of a state machine. The second is, given input, state machines will move through the states. It's kind of describing how a state machine works. This, have you all seen this picture before? Did Rob show you this picture? No, he hasn't yet? Okay, I guarantee Rob will show you this picture at some point. It might not be in this course, but I'm guaranteeing he's going to show it to you at some point in your academic career. Yeah.
Bloom's taxonomy also shows up in Intro to University.
Oh, really? Okay. Intro to University. Awesome. So some of you actually recognize this. I'm actually delighted. I didn't see this until I was an instructor. Yeah. I didn't see this until I was an instructor, and it was only because I chose to take courses about like how to be a better instructor. And so I want to share this with you because I feel like this unlocked a secret that I wish I knew when I was an undergrad student. Yes. When I was a student, I didn't know about this. And for me, a lot of the questions that were of the form, what does a state machine do? I'd get part marks on that. And I'd be like, but why? I answered the question. And it was really because I didn't answer the question that was actually being asked to me. What is a state machine is, I guess I should say this. Thank you for telling everybody what it was. And I do have a subtitle here, but this is Bloom's taxonomy. This is kind of like different levels of progress through like knowledge about something and your ability to use something. At the very bottom is the most basic part of somebody's ability to do something. Remembering here is really just about like, I've memorized all these facts. This works often quite well when there's lots of multiple choice questions on a test. Like I've memorized definitions of something, and the question, what is a state machine, is at the bottom here, where I'm saying a state machine has states, it has transitions, it has inputs that are being given to it. As we go up here, this is kind of like moving towards, at the very top, create. This is PhD level work. This is where you're like, given all the stuff that I've learned in undergrad, I'm going to make something new and contribute it back to the world. I'm making something new that nobody has ever seen before. I'm building this whole thing. So things like design, assemble, construct, develop, formulate, investigate, write, and present. To some extent, you can expect to see things like this starting to happen for you in 4,000 level courses, where you would be expected to actually do a design exercise in an HCI course. You'd be expected to write about that design. You'd be able to expected to possibly even give a presentation about the design choices that you've made. In 2,000 level courses and 1,000 level courses, we're usually kind of in the middle here. We're at the understand and we're at the apply phases here. So in a lot of cases, like I'm giving you lots of examples of code in this course, but I don't give you a complete implementation of a project. I give you enough so that you can then run with this and start applying those same kinds of ideas to your own projects in a bigger scale. In a 2000 level course, that's where we're at. And the question that I asked last time, what does a state machine do? This is kind of more in the middle. I want you to be able to demonstrate to me what a state machine actually does. I know that I gave you a tiny slip of paper to answer that question, but that's the kind of level of question that I was thinking about here. So one thing that this is the cheat code I want to give to you all, is just to have some understanding of these different levels, so that when you're looking at questions on tests, especially as you're going forward in your career in university, you'll have some idea of like where that instructor might be asking you to be, especially as you get through 2,000 and 3,000 level courses. In a lot of cases, we're moving past the remember part. We're at the understand and apply parts in 2,000 level. In 3,000, you're going to be doing analysis type level things, possibly evaluate, and then at 4,000 level courses, you'll be up at the very top of that triangle. Small aside, you don't need to know about Bloom's taxonomy for the test, outside of like kind of what I've just said here. Okay, so let me define state machine for you. I know that you all have a solid understanding of what a state machine is based on what you wrote, but I still want to make sure that we're all on the same page. When I'm thinking about state machines, I'm specifically thinking about the words deterministic and finite in front of it. These are machines that are not possibly infinitely big. They have a size. They are deterministic in that they will always execute in the same way when we're doing this, at least for what we're thinking about right now. If I have a state machine M and I have some input, it's going to consume input one token or symbol at a time, and it's going to use that symbol or token to transition between states. It's going to move from one state to the next state. I'm going to use Q to denote states here. Qi and Qj might very well be the same state. We might just go back to the same state that we're in right now. Given inputs, I move from one state to the next. The state that I'm moving from and to could be the same state. It could be to another state. And it could be to an ending state. I might just be stopping here. This is the end of input that I'm getting from this. Trigger warning, I'm going to show some symbols that are mathy. This is a state machine. A state machine consists of a bunch of different parts. First, Q is the set of states. These are all the states that we have in a state machine. Sigma is the alphabet. These are going to be the symbols or tokens that we have for our state machine. This is a finite set of symbols. There's only going to be so many symbols that we're going to have in the state machines that we're thinking about. When I'm thinking about a set of states, I'm going to go back here for a moment. When I'm thinking about a set of states, the set of states in this state machine is two states, locked, unlocked, and the start state, which is, so that's three, sorry, I should count. There's three states here. That black circle is the start state, and then we have locked and unlocked. In this, the alphabet is push and coin, but for us, when we're thinking about validating email addresses, the alphabet here is just characters, ASCII characters. That's what the alphabet is to me here. So like the actual ASCII character A is one of the letters or symbols in the alphabet that we've got. Delta is the transition function. And the way that this works or is defined is given the set of states and the alphabet, when we apply a symbol from the alphabet to the state that we're in, we're going to get some other state out of this. This, for us, is going to be like, I got a table. To go from state 1 to state 2, I'm going to accept this input. This, for us, when we're drawing this idea out, is going to be to go from locked to unlocked, I insert a coin. visually, that's what this idea of the transition function is. The transition function is all the arrows that we have in this diagram. Q0 is the starting state. Q0 is in the set of states. This is often for us, it will always be the black circle. This is the starting state. We have not consumed any input yet, so we have to start from somewhere. And then F, this is the set of accepting or final states. This is where we have ended input. For us, for this course, this is going to be, hey, thumbs up, yeah, we're done, we got a valid thing, or thumbs down, no, we don't have a valid thing. That's the end. That's the ending state for us. Yeah, I'm never going to talk about it like this again, just to be clear. I only really want to draw this as pictures. That's how I care to think about state machines. If you take comp, I don't remember what the course number is, so please forgive me, but the theory course at the 3000 level, you will learn and see this a lot more. You'll see this a lot more, but for me, I really just want to draw this out as diagrams. That's how I want to think about state machines in this course, because at least for me, that's how it works. Like when I'm thinking about state machines, bubbles and like graphs and stuff are actually showing up in my head. That's how I'm mentally modeling state machines. So I want to do a state machine that's going to validate email addresses, and I want to visualize this idea along the way. I want to make a minor aside before we even start thinking about validating email addresses. My minor aside to you is, as you go out into industry and you actually start to do stuff like this, the best way to validate an email address is to send an email to the email address. That is the best way to validate whether or not an address is a valid address. You've been involved in this flow a lot. You type your email in, it sends you a link, and then you click on that link. That is validating your email address. That's what's happening with that flow. The best way to validate that an email address is valid is to send an email to it. If you didn't get it, you either didn't type it in or it showed up in your spam box, but this is going to stop like invalid things from showing up here. I want to use a state machine to validate email addresses. And to answer this question, we kind of have to start with what even is an email address. I'm going to draw on an RFC. RFCs are kind of how internet technologies are codified. This is like something that gets published. This is a request for comments. It gets published to the wide world, and people who are writing software for the internet will then read these specifications, and they will use those specifications to do things like create your web browser for you. So RFC 822 here. Well, I'm going to have to Google search this because I haven't even put a correct link into my slides. I'll fix that after class, sorry. RFC 822 is the internet message format. This describes in excruciating detail how things like emails are structured. Section 3.4.1 here. 3.4 is the address specification, and 3.4.1 down here is this address spec specification. This really is the high-level description of what a valid email address is. You don't need to memorize these numbers, just to be clear. The thing that's important to us is that we have this statement of, we have a local part, we have the @ symbol, so that word cloud where we've got giant @ in the middle, awesome, yes, that is absolutely a main thing that's required as part of this. And then we've got a domain that appears after that. Let's draw a state machine to represent this idea. We're going to go through the process of building up this state machine iteratively. I'm going to expand on this to add new information to it as we're going through the structure of this, but we're going to start with just this basic idea here. So I'm going to switch over to my tablet. I'm going to try real hard to switch over to my tablet here. Oh, wow. That was very loud. I'm going to switch over to my tablet here. Okay, awesome. If you're watching on the live stream right now, you can like look up my nose, I guess. We're going to switch over to my tablet here, and I want to draw a state machine that really represents this idea. We're going to start drawing our state machine with a start state, and we're going to have a single ending state. This is start, and this is end. These are the two core parts of the thing that we've got. In the diagram, or in the address specification that we were just looking at, there were three parts to it. There was the symbol in the middle that was the @ symbol. And so I'm going to have a state that represents the @ symbol. On either side of this state, I'm going to have another state that represents, I'll use the same one here, the local part. And the domain part. I'm going to call it domain. I forget what it says there, but I'm going to call it domain. To go from, so to transition from the start state to the local part, we're going to accept input. And the input here is going to have to be a symbol that is not the @ sign. The way that I'm going to describe this for us in this course, I'm not saying this is a universal standard for state machines. I'm just going to describe it this way for us because this is what's clear to me. The thing that we're going to use to represent that idea is I'm going to use an exclamation point. So not the @ symbol. And in fact, I'm going to change this slightly. I'm going to erase that. Sorry if you're feverishly writing this down with me. I'm going to change this slightly to be, I'm going to accept as input letters. Does that seem reasonable to everybody to accept letters as input as part of what this domain is or local part is? Okay. I'm going to describe letters this way. So I'll annotate this, and what I mean by this is any character A to Z. This technically means lowercase characters A to Z, but we'll just kind of hand wave it and say letters. That's what we're expecting as input here. When we're thinking about this state machine, this is using exactly one symbol to go from the start state to the local part initially. I'm going to come back to this in a moment. I'm going to go to my slides here, and I'm going to say we've got two valid email addresses here. One of them is walter@example.org, and the other is julio@example.com. When we adopted Walter from the Humane Society had given him the name Julio, so we'll say that he has changed his email address over the years. I'm going to write at the bottom of my diagram here, Walter, @example.org. For us to go from the start state to local part, we will consume the W here. That will be the value, that will be the token, that will be the symbol that we're consuming as part of using the state machine. It is a character in between A and Z, and so we will move from one place to another here. Next, I'm going to need to consume the rest of Walter up to the @ symbol as part of my state machine. And so for that, I'm going to want to stay in the state that we're in here. I'm going to have a self loop. I don't want to leave the state. I just want to stay in the state. And the self loop is going to have the same property here. It's going to accept A to Z. Accepting A through Z, we start at the start state, we consume the symbol W, and we move to the local part. That's our first arrow here. And then once we're at the local part, we're going to consume A, self loop, L, self loop, T, self loop, E, self loop, R, self loop. Then we hit the @ Now we want to move from that state into the @ symbol. So I'm going to go from here to here. And the only way we should be able to move from the local part to the @ is if we consume the @ symbol. So I'm going to write just above this, I'm going to label this line. The only acceptable way to go from local part to the @ state is that we have consumed the @ symbol. For both of these, we're going to add some more outgoing edges later, but for now, if we're just accepting this input, going from the R to the @ here, that's going to take us from the local part to the @ state itself. I'm going to write just above here, this is exactly one @ symbol. This is exactly one @ symbol that we're consuming to go from our local part to the @ state. To leave the @ state, so we've read this @ symbol here. To leave the @ state now, we're going to have more symbols here that are of the form A through Z. And then kind of like we've got with the local part, we're going to want to have another self loop here. To go from the @ state, this transition here consumed our @ symbol, and then at that point we are in the @ state. To leave the @ state, I'm going to consume one more symbol here. So this is the E. That E is going to be taken up by this transition, but then we have a bunch of leftover input here. So we have this xample.org. All of that is going to be input that's part of this domain part. So for this, we're going to have another self-reference. We're going to want to accept as input as part of this A to Z. And also a final symbol here. We have to add to this the dot. Mark this up to make sure we remember what it is. This is a literal period. This is an actual dot. Like there's a dot in the dot part of a domain name. So I have to have a dot here. When we're in the @ state, we're going to consume this input. E to go to the domain part. And then within the domain part, we're going to start consuming the rest of this. X is part of A through Z or dot. A is part of A through Z through or dot. M, P, L, E. These are all going to be consumed by the self loop in this state. The dot is going to be consumed by the self loop. O, R, and G will be consumed by that self loop. Once we've consumed all of the inputs, then we're going to be able to go from our state for the domain part, we're going to go to the end state. And here is where we're going to be able to say, green check mark, this is valid because there is no more input. For all the other states, I'm going to draw this once, but I'm probably not ever going to draw this stuff again. For all the other states, we have to have like an outgoing line to an error state. I'm going to move this up just a little bit, and I'm going to give you an example of an invalid email address. So I'm going to put a check mark beside Walter here. This one is a valid email address. Here's an example of an invalid email address. Do we agree that's an invalid email address? That's an invalid email address, yeah. This is not a valid email address. So I have to have something that goes from the start state that's for basically everything else to the end state. I'm going to draw one more line here, and I'm going to mark it in the same red color. And what I'm going to put on this as the inputs that it's accepting to go to that state is asterisk. The asterisk, to me, means everything else. As we're going through these state transitions, we're going to match the thing that most closely fits with what we've got. To go from our start state to either the local part or just to the end state and say, no, this is not valid, we're going to consume the first symbol in the input that we've got here. The W matches most closely with the accepted input. The @ matches most closely with the rejected input here and kind of goes to that end state. Yeah.
The end state now representing two different things, either a valid email address or not. It wouldn't be like two separate things, like two in one.
We can have two end states here if we want. So I could have an end state here that is marked as green for accepted, and I can have an end state here that's marked as red. F for us, if we go back to that formal definition, F is a set of end states. So both of these are end states. Yeah. 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 So this entire thing here letters or the literal period symbol, yeah. A valid email could have no period. A valid email could have 17,000 periods in it, yes. Yeah. This is not a good state machine. This is not a good state machine. As it is right now, this will accept valid email addresses. It will. It definitely will. But it will also accept lots and lots and lots of invalid email addresses. To be super duper clear, we're never going to get to covering every possible invalid email address. I'm going to go back to my slides for a second here. Here are some more examples of valid email addresses. Here's a small life hack for you, at least with Gmail, and I think this is true of lots of different providers. The thing that's before the plus is your like username, and the thing that's after the plus is your own personalized filter for whatever you want. So like Walter plus pizza at gmail.com would go to Walter at gmail.com, but it would have plus pizza in the email address so that Walter could say, oh, these are all my pizza deals that I want to be categorized in this folder. This is definitely true of Gmail, and I believe it's true of lots and lots of other other email providers. Many of you have emailed me. You know that there's a dot in my username before my @ symbol. I'm going to go down here, and I'm going to tell you that you can also have quotes around an email address. And this is going a little bit to the point of absurdity, but this is what is specified by that specification. These are valid things. If I want to add this plus symbol, we can. The simplest way to do that would be to do kind of like what we did with the dot, and to just add that here. That would be one way to do it, but this now means things like we could have just plus as an email address, and that's not a valid email address. To accomplish this correctly, what we would need to do is take this local part state and split it into several states. The things that are before the plus, the things that are after the plus. Much in the same structure as we've got here. We've got a local part, and then an @ state, and then a domain part. If I wanted to correctly allow this to happen, to have these pluses, I would take local part and I'd split it into 3 states, a lot like what we've got here. The username, the plus symbol, and then everything that comes after the plus symbol, but before the @. I'm going to go back here. And I want to show you a state machine that can validate email addresses. Well, I'll keep scrolling down, but it won't help. Email addresses are complicated. Email addresses are complicated. So to the person that wrote, that's a complicated question, like big thumbs up. Yes, this is a very complicated question. This is also not correct anymore because this is a state machine. This is a regular expression. Have any of you heard of regular expressions? A few of you have. Okay. Regular expressions are state machines. They're just a text representation of a state machine. It describes how you can match text, and really matching text is what we're doing here. Given walter@example.org, we're taking symbols through the state machine to see whether or not it matches, or if there's any place like we've hit this @ symbol, but I don't have an A to Z, I'm going to go to this error state and I'm going to reject it. I'm going to say that no, this is not a valid thing. This is one way to represent that, but it is kind of old and it's been replaced several times. RFC 5322 is the one that we're actually thinking about right now. And while the regular expression is vastly smaller, the state machine that represents that, can you imagine if I tried to scribble this all down in the next 10 minutes? It's not going to happen. Like, validating email addresses is complicated business. The really big thing that I want you to take from this exercise right now is that we've got a state machine here, and as part of the state machine, we have transitions between states, and we've built up a state machine effectively from examples of input. We really didn't, but we could build up a state machine by saying, to go into this local part state, I can accept these symbols up to this @ symbol. Once I hit the @ symbol and I recognize that this is part of all the things that I've got underneath it, we can make an @ state here, and then we can go through the rest of this process to match the rest of it. The key things that I really, really want you to get are, there are states. There are transitions between states. As we move from one place to another, we're consuming some kind of input to get from one place to the next. This is a tool that can be used to accept input. We have a success final state, and it can be used to reject output. We have a failure ending state here. Those are the key things I want you to get out of this conversation. Are there any questions about this? I'll share this diagram with you on the course webpage after class if you haven't been able to hastily type it all down. Yeah.
Since you said this is not like that state machine, we expect for the project, for example, we expect how close to the valid state machine are we?
For your test, I'm going to expect you to do this perfectly. Major sarcasm, if that wasn't clear. No, absolutely not. I'm not going to ask you to do this as part of your project either. This is a stepping stone for us toward Markov chains. I believe that you should be able to use the idea that we've got here to validate input in general, not email addresses, but input in general. But I'm not asking you to do that as part of your project, and I'm not asking you to do that necessarily directly as part of your test. But please do memorize this. Yeah. Any other questions about this? Yeah.
Kind of like when we have our flows of interaction that take into this kind of, if we zoom in into one of those like rectangles, that is what's happening there.
So your question is about just restating it for the audio here. Trying to make a connection between flows of interaction and state machines. Superficially, yeah, I think they are superficially similar to each other, but they are different means to different ends. One of them is more about, it's not really a machine that's consuming input and maintaining states in any way. It's more of a visual depiction of what we would expect an implementation of this to look like and how we'd expect it to work.
So it's not really a
It's not really a state machine, no. You can think of it like it is a state machine, as though like the state right now is I'm getting these inputs, and then the next state is I'm doing processing, and then the next state is I'm showing these outputs. You can superficially think of it that way, but beyond that superficial comparison, I'm not sure that there's a direct relationship between the two ideas. Okay. One of the things that we didn't talk about here is that like there can be backslashes, and then there's these symbols here that are not even printable characters that can be part of a valid email address. The best way to validate an email address is to send an email to it. As you get out into your lives, please do not try to validate email addresses beyond like, okay, thanks for giving me your email address. I'm going to send you an email. That is absolutely the best way to validate if an email address is a valid address. Let's take a look at some code that implements a state machine to validate the simplistic view of what we have of email addresses. I've put this up on the course webpage as a link to a repository alongside today's lecture notes, but I'm going to have it up here on my screen so that you can all take a look at it. Another trigger warning, this is C. I'm showing you C code. I'm not showing you TypeScript today. Part of this is the language doesn't really matter. The language is not really important. It's kind of how we can structure state machines. When I talked to John yesterday, he said to me that at least in his class, he showed state machines approximately in C++ and JavaScript last term. And so I'm going to give you an alternative view of that structure, and it might match what you've got. There's a lot of stuff here that you can safely ignore, but we've got some context. This is going to be responsible for keeping track of what token we're currently consuming and what the next state for us should be based upon the token that we've just consumed. So in the diagram that we've got here, this is keeping track of, I'm looking at W right now, and the next state that I have is going to be this state in the state machine. It's also keeping track of the whole input. This is the entire input that we've got, but current symbol is, this is the letter I'm looking at right now, and this is the state that I'm going to look at. I have an enumeration. This is a good use of an enum, and our enumeration here is, these are the states that we can move through. These are all the states that we can move through. The states that we can move through here are represented by functions that are going to consume input for us. So local part is, as our local part state, it's going to have a loop inside of it that's going to consume inputs that match A through Z. The @ symbol is going to consume just one @ symbol. That's all it will ever do, and then it will go to the next state. The domain part is going to consume the A through Z and the dots, and it will only consume those symbols, but there will be a loop in it that consumes those things. Here's a real scary looking part on lines 27 through 32. This is a table of function pointers. Oh boy, I'm so happy I got to say that in class today. This is a table of function pointers. You have used first-class functions in JavaScript. In C, you can refer to a function by its name, and you can refer to it by its address. And this is approximately the same superficial, high-level idea as a first-class function in JavaScript. This is a strange-looking array initialization, but what this is really allowing me to say is that at specific elements, I can initialize what those things are. This type def here is just a way for me to really simplify the transitions between this. This, for us, is delta. This is that function that's going to take the state that I'm in right now, ultimately, and connect it to the next state. This is how I'm going to use this thing. I've got a start state here, and it is the local part. And then I actually have design by contract. I'm applying my own thoughts here about this. I'll let you read that part on your own. In our main function, we have some initialization set up. And this loop right here is the real core of this whole thing. This drives the state machine. I'm going to set up some initial context, and then I'm going to go through and I'm just going to run functions. I'm going to run a function that's going to give me the next state of input. This line at first is going to go to the start state, which is the local part of our email address. And it's going to run the local part. The local part will have a loop that will consume all of the symbols that it can up until it hits that @ symbol. And then it will say, this is the next state that you should go to. Or, I've got an error. This is not a valid email address. When we return back to our main function, that takes us to the @ symbol then. It consumes the @ symbol, or it doesn't. And then it tells us that this is a valid or invalid email address, or to go to the domain part or an invalid email address. The domain part then does approximately the same thing. It goes through the process of consuming symbols up until it can't anymore. And it's either because it's gotten to the end of the email address or it's encountered a character that is not recognized as part of what's expected here. This is available on the course webpage for you to take a look at if you want to, but the language itself is not important. It's the overall structure of what this thing is doing. At this point, you should be able to, given this kind of input, given this kind of abstract structure of a state machine, you should be able to implement a state machine that ensures applications take only acceptable input and reject invalid inputs. That's it for today. I hope you all have a great rest of your day and a great weekend, and I will see you all next